Welcome to this explainer. Okay, let's jump right in. We are going to tackle a massive, honestly, kind of unsettling paradox right off the bat. You know how we're taught from a very young age that space is just this near perfect vacuum? Like without air or any medium for sound waves to travel through, the cosmos should be completely, absolutely silent? But here's the crazy part. Scientists have actually found a way to listen. We have literally heard the universe scream. Now, you're probably wondering, how is that even physically possible? And just to be clear up front, NASA isn't, stringing a bunch of microphones out into the void. Instead, think about it like this. Every planet, every star, and every black hole out there is emitting energy across the electromagnetic spectrum. Instruments on spacecraft like Voyager, Juno, and the Solar Dynamics Observatory are actually recording these emissions as raw data. They capture plasma vibrations and particle data as they hurtle through the dark, and that data leads us to a seriously incredible process. That process is called sonification, and understanding it is absolutely crucial for this explainer. These eerie sounds we're about to explore, they are not just artistic interpretations. They aren't sound effects whipped up for some sci-fi movie. No, they are direct, rigorous, scientific translations of actual cosmic activity. Basically, researchers take that raw data and map it onto the audio spectrum, rendering it audible so we can finally experience what our eyes alone just can't see. And let me tell you, what comes back is definitely not random noise. Let's start with our first cosmic sound. Section 1, the dead star's heartbeat, specifically looking at the Crab Nebula pulsar. So, located roughly 6,500 light-years away in the massive wreckage of a supernova, we have this specific pulsar spinning at just incomprehensible speeds. We're talking rotating roughly 30 times every single second. Imagine that. As sweeping beams of intense electromagnetic radiation blast from its magnetic poles and wash right past Earth, our instruments catch them. And when that raw, sweeping data is sonified and converted to audio, the result is this steady mechanical rhythm. It is just relentless. But here is the really crucial point. Our human brains are totally hardwired to find patterns, right? We desperately want to hear this rhythmic, organic pulse as a living heartbeat buried deep inside the corpse of a dead star. But it is entirely lifeless. It mimics the absolute most fundamental rhythm of life we know, sure, but really, it's just the cold, haunting physics of a collapsed star spinning out there in the dark. Moving on to number 2, Jupiter's screaming magnetic field and its auroral radio emissions. Let's zoom back into our own solar system for a minute, because the sheer difference in scale here is just wild. Jupiter's magnetic field is a staggering 20,000 times stronger than Earth's. To put that into perspective, if we could actually look up and see it in our night sky, it would look 5 times the size of a full moon. Now, when charged particles from solar winds slam into a magnetic shield of that massive magnitude, they generate these intense, honestly terrifying radio emissions. NASA's Juno spacecraft actually captured these emissions during its flybys over the planet's poles. Down there, auroras are raging constantly. And we aren't talking about our nice flickering green northern lights. These are permanent curtains of ultraviolet fire. When scientists sonified this environment, the soundscape it produced completely defies description. You hear these distorted wails, really sharp whistles, and what sounds exactly like actual screaming. It is the literal sound of the planet itself, a massive gas giant just screaming out into the void. Okay, we definitely need a quick breath after that intensity. So let's look at number 3, the comet's haunting song, Comet 67P. This recording was captured back in 2014 by the European Space Agency's Rosetta probe, right off a 4-kilometer-wide chunk of ice that totally defied all scientific expectations. So interactions between the comet's surprisingly strong magnetic field and the solar wind were producing these strange oscillations. And when they converted it to audio, it didn't sound like static. And thankfully, it didn't sound like screams. It produced this really quiet, oscillating hum. It rises, it falls, it almost breathes. It remains one of the absolute most beautiful and really inexplicable recordings ever captured. Why? Well, mostly because scientists still cannot fully explain the exact mechanism generating a magnetic field strong enough to produce this exact pattern. But, as you might guess, the peace in space doesn't last for long. Number 4, Saturn's organized electrical violence, exploring the radio waves of a gas giant. The Cassini spacecraft detected something deeply, deeply unsettling happening inside Saturn's atmosphere. Get this, we are talking about continent-sized thunderstorms, winds exceeding 1,800 kilometers per hour. a place where hydrogen compresses so much it actually falls as metallic rain. Now, on Earth, a lightning strike is a sharp, distinct pop, right? On Saturn, the lightning discharges generate radio waves that sound like these long, stretching, tearing hisses. The strikes literally last for seconds, which is an absolute eternity in electrical terms. But you know what the truly terrifying part is? It isn't even the raw electrical violence. It's that beneath all the static and the chaos, researchers found structure. The rhythms of those crackles and pops are organized in a way scientists did not predict, and frankly, still don't completely understand. It's not just random. For our final mystery, we're turning to something that challenges our very comprehension of scale. Number 5, the black hole's eternal drone in the Perseus galaxy cluster. Back in 2003, astronomers pointed the Chandra X-ray Observatory at the center of the Perseus cluster. That's about 240 million light-years away, by the way. And as its supermassive black hole devours matter, it generates these unbelievably powerful pressure waves. They ripple through the surrounding gas that is heated to literally millions of degrees. When scientists mapped these specific waves into sound, they found a note so deeply resonant, it is the absolute lowest note ever detected in the known universe. It sits 57 octaves below middle C. That is so far below the threshold of human hearing that NASA had to shift the pitch up 57 octaves just so our human ears could even perceive it. Just think about the scale of this phenomenon for a second. This sound is not just loud, it is vast. A single wavelength of this sound stretches across tens of thousands of light years. It's mind-blowing. It perfectly represents the sheer, completely physics-defying scale of matter being consumed by a supermassive black hole. What we're listening to is quite literally the sound of an abyss. But what makes this so incredibly haunting is the actual nature of the sound itself. Because let's be honest, scientists totally expected the audio of a supermassive black hole consuming matter to just be chaotic, right? They expected random, incredibly violent noise. But instead, they found this sustained, grinding tone, an abyss, singing. And here's the kicker. It doesn't stop. This unimaginably deep note hasn't just been playing for a few hours or a couple of days. The pressure waves actually revealed that this exact black hole has been humming this specific grinding frequency continuously for 2.5 billion years. Guys, long before multicellular life even existed on planet Earth, this cosmic drone was already echoing out through the Perseus cluster. So from the lifeless heartbeat of a pulsar to a gently singing comet, and finally to the eternal 2.5 billion year drone of a supermassive black hole, I think it's pretty clear. The universe is far from silent. We are really only just now beginning to develop the tools to map and actually listen to the cosmos. So I gotta ask, which of these sounds stayed with you the longest? And more importantly, as our sonification technology gets better and better, what else is the universe saying that we just haven't figured out how to hear yet? Thank you so much for joining me for this explainer. Keep your curiosity alive, and I'll see you in the next one.